This is First Class Maths' practice paper for paper 3, AQA, and these are my video solutions for it. So I hope you find it helpful. Hopefully it helps you with the answers. Question number 1, x is a positive integer, so a positive whole number. Write down the value of x to the power of 0. Well, we know that anything to the power of 0 is going to be 1. For question 2, simplify 3m to the power of 6 multiplied by 9m to the power of minus 2. So 3 times 9 we can do, and that's going to give us 27. With m to the power of 6 multiplied by m to the power of minus 2, when we multiply, we add the powers. So I'm doing 6 add minus 2, and that's the same as 6 take away 2. So we've got m to the power of 4. For question number 3, factorise fully. Now that fully is a clue that perhaps not just a single thing is going to come outside the bracket here. And if we look at both these terms, factorise means to put into brackets. We only need one bracket because these terms have a common factor. The numbers 5 and 12, the highest common factor is 1, so that's not very helpful to us. But x cubed and x squared has a common factor of x squared. So we can take that outside and we would be left with 5x here. X squared times 5x is 5x cubed. And then add 12, but we don't need any more x's because x squared times 12 would give us the 12x squared that we wanted. For question number 4, Jake thinks of a number. He multiplies his number by m to get a new number. His new number is 6% greater than his original number. Write down the value of m. So Jake has multiplied by something that has increased his number by 6%. So we've times by m, and that has made it 106%. So that's the same as multiplying by 1.06. If you want 106%, to get that, we can multiply by 1.06, which is 106% as a decimal. So 1.06 is our answer there. Question number 5, write down the reciprocal of 0.8. 0.8 is 4/5. And if we do the reciprocal of that, we're inverting that fraction. And so that would become 5/4. You can put it as a decimal if you want. You'd be absolutely fine to write 1.25 here. That's 5/4. But 5/4 is absolutely fine. Another way to do it in your calculator would be to do 1 divided by 0.8. And that will give you the same answer as well. So if we multiply a number by its reciprocal, it should give us 1. So 1 divided by 0.8 would get that answer. For question number 6, A to B to C is in the ratio 4 to 5 to 12. Write a fraction in the box below to complete the statement. B is something of A. So let's look at the ratio A to B. A to B is in the ratio 4 to 5. So B is 5 parts when A is 4 parts. So if I had a value that was on this side, if I wanted to get it to this side, I would need to divide by 4 and multiply by 5. So to get from A to B, we're going to be timesing by 5/4. So 5 divided by 4 is that decimal multiplier. So that's what we're going to pop in there. For part B, write an integer, so a whole number in the box below to complete the statement. C is something percent of A. Well, the ratio A to C is 4 to 12. And we can see that that's been multiplied by 3. So C is 300%. It's 3 times bigger, so that is 300% of A. Question number 7a, write the number 4 million in standard form. So 4 million looks like this. It is a 4 in the millions column. And to write that in standard form, we need a number between 1 and 10. Can't equal 10, but it can equal 1. So 4 multiplied by 10 to the power of 6. That would be, it is 4 times by 10, 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 6 times. So 4 times 10 to the power of 6. For 7 part B, the number 7.2 times 10 to the power of 50 is written as an ordinary number. How many digits will it have? So every time I multiply by 10, those digits are going to move one place value column to the left. So when I times it by 10 the first time, it's going to go from 7.2 to being 72. So I've times it by 10 once and it's become 72. Now I'm going to do that 50 times, but the first time I did it, it ended up with 2 digits. So if I'm going to do it 50 times, but it started with 1, it's going to be 51 digits in total, because every time you're multiplying by 10, it's moving one place value column over. Question number 8, shape A and shape B are shown on the grid below. Rotate shape A 90 degrees anti-clockwise about -1, 1. -1, 1 is here. If I'm going to go 90 degrees anti-clockwise, then we're going in the opposite direction to a clock, so we're going to go this way here. Now this is when you'd put your tracing paper over the top, you would draw round A, and you would spin it 90 degrees until it is facing that way. What would happen, this point here, at the minute, it's 3 down and 2 left, it would end up here. So that's going to help me slightly. When I spin it, it's going to look like this and be here. That's C. And then for part B, reflect shape B in the line y equals 3. So y equals 3 goes through the y-axis at 3. So the line y equals 3 looks like this. Goes through 3 on y. And so we're going to reflect, let me get rid of this, we're going to reflect the shape in that mirror line. So let's do that here. The same distance away on both sides, so it would look like that. That's the line y equals 3, goes through 3 on the y-axis, and however many squares away from the mirror line you are on this side, it's going to be the same on that side. So what shape, what letter do we have to call that one? Let's have a look. That's going to be D, of course. There we go. Question number 9. Here is a cuboid made from metal. The mass of the cuboid is 1 kilogram. Work out the density of the cuboid in grams per centimetres cubed. So we've got centimetres, centimetres, centimetres here. I've got grams per centimetres cubed as my density. So I'm going to need that density formula triangle. Density, mass, volume. And if the density is in grams per centimetres cubed and the volume, once we work it out, is going to be in centimetres cubed, then we're going to want to make sure that the mass is in grams. So 1 kilogram is 1,000 grams, so that's what we're going to use. The volume of a cuboid is found by doing the area of the cross-section multiplied by how far back it goes. In this case, we could just do 4 times 3.2 times 9.5 in any order. That's going to be fine. So I'm going to type that in my calculator. 4 times 3.2 times 9.5. And that's going to give you a volume of 121.6 centimetres cubed. Now work out the density. So if we want the density, cover that up and do the sum that's left behind. So we're going to do mass divided by volume, which is 1,000 divided by 121.6. 1,000 divided by 121.6 gives me a density of 8.22368, and so on. We're going to give that to, let's just go for 3 significant figures, 8.22. Question number 10. The bearing of A from B is 80 degrees. Work out the bearing of B from A. So let's give this a little sketch. 80 degrees going round is going to be just less than a right angle. So like this, the bearing of A from B. So if we're stood at B, from B, this is the bearing of A and it's 80 degrees. I would now like to know the bearing of B from A. Now remember, bearings start north and go clockwise. So I'm actually going to give this angle. Now there's a couple of different ways that you can work this out. Using co-interior angles, if this one is 80, then this one over here is going to be 100 because the lines going north are parallel. And so they're co-interior angles, they would add to make 180. I can then take that away from 360 and that gives me 260 degrees as my bearing. The other way to think about it is you could think about alternate angles. You've got that Z shape there, so alternate angles are equal. This angle would be 80, and we know this side is 180, so adding those two together gets you 260. Question number 11. Here is a triangle with an area of 330 centimetres squared. Work out the perimeter of the triangle. So we know that the area of a triangle is base times height divided by 2. So 60 multiplied by x, because we don't know the height at this moment in time, divided by 2 equals 330. Let's solve this equation then. We're going to do that by multiplying both sides by 2. That gets rid of the fraction. So 60x equals 660. and then we're going to divide by 60. So x equals 11. So x equals 11, and that tells us then that that is the height. So I can pop that there. I then want to know the perimeter of the triangle, and the perimeter is the distance all the way around the outside. So 60 add 11 add something, let's call it y. Now to get y, we're going to use Pythagoras. So 11 squared add 60 squared, and then we're going to square root that answer to find out what y is. 11 squared add 60 squared is 3,721. Let's then square root that answer, and that gives us 61. So 61 is the hypotenuse. Now let's add all of that together to get the perimeter. 11 add 60 add 61. And that gives us a final answer of 132 centimetres for 5 marks. Okay, question number 12. The first two terms of a sequence are shown below. We've got 10, 15, something, something. Devon assumes it is a linear sequence. Work out the next term of the sequence using Devon's assumption. So linear would mean it would be going up by the same amount each time, adding on the same amount. If you plotted it on a graph, it would make a straight line. So he's assuming if it's add 5 there, that it's going to be add 5 again, and add 5 again. So adding 5 each time, the next two terms, or work out the next term, is just going to be 20. So adding 5, let's do some working, 15 add 5 is 20. For part B, Sarah assumes it's a geometric sequence. A geometric sequence is when we're multiplying each time. So to get the multiplier, we would do 15 divided by 10. 15 divided by 10 is 1.5. So that means it's multiplying each time by 1.5. So 10 to 15, that's multiplied by 1.5. And to get to the next term, we're going to multiply it by another 1.5. 15 times 1.5 gets us 22.5. So if it was geometric, that would be the next term. For part C, Morgan assumes it's Fibonacci type sequence. Work out the next term of the sequence using Morgan's assumption. So Fibonacci is when you add the two terms to get the next one. So 10 add 15 would give us 25. And then if we were going to carry on again, we'd do 15 add 25 and we'd get 40. But we only have to do the next one. So 25 would be our answer there. Chuck assumes the sequence is the triangular numbers starting from 10. Work out the next term of the sequence using Chuck's assumption. So triangular numbers, think about the format of the pins when you go bowling. So the first triangular number is 1, then we have 3, then we have 6, then we have 10 pin bowling, then we have 15, 1, 2, 3, 4, 5, and the next one would be got by adding a row of 6 along the bottom. So we just had 15, we would then add 6 more underneath, so 21 would be the next number if we were using Chuck's assumption. There we go. Question 13, P and Q are consecutive cube numbers. Both P and Q are greater than 100 and less than 1,000. The difference between P and Q is a square number. Work out this square numbers. Okay, let's think about our cube numbers then. So we know that 5 times 5 times 5 is our first cube number that goes over 100. So that's 125. 6 cubed, 6 times 6 times 6 is 216. 7 cubed is 343. 8 cubed, now I'm going to have to turn to the calculator now. 8 cubed is going to be 512. I did know that one. 9 cubed is going to be 729. And 10 cubed would be 1,000, so that wouldn't be less than 1,000. So there we go. They're all the cube numbers that it could be. And we've got to use consecutive cube numbers. So I'm looking at the difference between them and seeing if it's a square number. So 216, take away 125. Let's see what that is. That gives us 91, and that is not a square number. So let's try the difference between these two. 343 minus 216, that is 127, not a square number. Let's try the difference between these two. 512 take away 343, that's 169, and that is a square number. So that's actually 13 squared. So you could write out all the square numbers, but 169, the square root of that is 13. So 169 square rooted is 13. So there we go, we found it. So P and Q are consecutive cube numbers. Both P and Q are greater. So work out this square number. It's the square number we have to give, and that is 169. Question number 14. Exterior angles of a regular octagon to the exterior angle of a regular decagon is in the ratio n to 1. Work out the value of n. So the exterior value, if you imagine an octagon, 1, 2, 3, 4, 5, 6, 7, 8. The exterior value, angle, is that one there. And to get that, we do 360 divided by the number of sides. So the exterior angle of an octagon is going to be 360 divided by 8, which is 45 degrees. The exterior angle of a decagon is going to be 360 divided by 10, which is 36. If we put that in a ratio, it will be 45 to 36, but we've been asked to make that right-hand side value 1. What have I done to the right-hand side to make it 1? I've divided by 36, so I also, to keep this ratio equivalent, need to divide the left-hand side by 36. 45 divided by 36 is 1.25. Now, we normally wouldn't allow decimals in ratios, but when you've been given, or just what's n, there we go, 1.25. When you've been told to make one of the sides 1, the other side is whatever it has to be to keep it equivalent. Question number 15. ADF is a straight line. Line AB is parallel to line DE. A to C is equal to B to C. So that's an isosceles triangle at the top there. Work out the size of the angle marked X. Give reasons for your answer. So what I'm going to look at here is if there are any alternate or corresponding angles. Now remember, Z, that makes your alternate angles, and that F shape, that makes your corresponding angles. Corresponding and alternate is how I remember them. So I'm going to have a little look for that. And if I look here, I've got that corresponding angles, that F shape there. So this angle here, 108, and this angle all the way to that parallel line would be equal to 108, both of them, because corresponding angles are equal. So the first thing I'm going to do is write BAD, this angle here, angle BAD equals 108 degrees because corresponding angles are equal. And if I know that that is 108 all the way, then this bit here must be 28 degrees because I've done 108 take away 80. Now, that's an isosceles triangle at the top. So if that one's 28, then this one is also 28 because base angles in an isosceles triangle are equal. So let's put angle ABC because base angles in an isosceles triangle are equal. I apologise for my handwriting. And then we know that X will be whatever it needs to be to add to make 180. I'm looking at this triangle here, and angles in a triangle add up to 180. So I'm going to do 28, add 28, which is 56, and then 180, take away 56 is 124. So we know that X equals 124 because angles in a triangle add up to 180 degrees. So the answer we're looking for is 124. Question number 16. Here's some information about the masses in kilograms of 80 horses. Draw a cumulative frequency graph. So this is just the frequency. If we want cumulative frequency, the categories are going to be slightly different. So instead of it going 300 to 400, that first one is still going to be that. And we know that there were 9 horses in that category. For the next category, it's going to go 300 to 500. So all of that data from 300 up to 500 is now going to be included. So we need to add on that 13, and that is 22. We're then going to go from 300 up to 600. So we're now including that 24 as well. So that's going to be 46. Then we're going to go from 300 up to 700. So add on the 21, and that's going to be 67. And then we're going to go from 300 all the way up to 800, so add on the 13 and that gives us 80. That top number should match the number of pieces of data altogether. We're then going to draw that graph and we plot at the top of the category. So we're going to go across to 400 and up to 9. We're then going to go, let's make that a little bit clearer. So that would be in the middle of that box. We're going to go across to 500 and up to 22. There. We're then going to go across to 600 and up to 46. So we're plotting in the top of the category each time for the cumulative frequency. Across to 700 and up to 67. And across to 800 and up to 80. We're then going to join that up with a nice smooth curve. Like that. Lovely. For part B, use your graph to estimate the median mass of the 80 horses. So if we've looked at the weights of 80 horses, we're going to be reading across in the middle. So we're going to look at the 40th horse. So get your ruler, read across at 40, hit the graph and go down. Now for me, that is bang in the middle of that box. So let's have a look here. This would be 550. So I'm going to say 575 for that. You might be slightly different. I'd probably go half a square either side maybe. As long as you're reading correctly off your graph and you're within a small range of that, you should be absolutely fine. So 575 kilograms there. For question 16C, horses that have a mass of less than 380 are considered ponies. Use your graph to find an estimate for the proportion of the horses that are ponies. So we're going to go to our graph, we're going to go to 380 and we're going to read up and we're going to go across to work out how many ponies that is. And I'm going to say that that is 6. So I've got 6 there. 6 ponies out of the 80. So that would be fine. We can just say 6 out of 80 that are less than 380 kilograms. That would be your proportion. You could put it as a percentage if you want, but 6 out of 80 is a proportion. That's absolutely fine. Question number 17. Work out the highest common factor of 20x to the power of 4 y to the power of 12 and 15x to the power of 8 y cubed. So I'm actually going to use my Venn diagram for this just because I feel like it's a really nice demonstration. So let's make this circle 20x to the power of 4 y to the power of 12 and this circle 15x to the power of 8 y cubed. What can we put in the middle? Well, 20 and 15, they both have 5 as a factor. So we need to put 4 on the outside here and we need to put 3 on the outside here. There's nothing else in common. With x, we can put x to the power of 4 in the middle and then we're left with x to the power of 4 out here. When we times them, we would add the powers. And then with y, we've got y cubed in the middle, and we can put y to the power of 9 out here. So our highest common factor is everything in the middle multiplied together. It's the biggest thing that fits into both, 5x to the power of 4 y cubed. If we then look at that, exactly the same numbers, but we're doing the lowest common multiple, we need to multiply everything in that Venn diagram together. So 4 times 5 times 3 is 60. I've got x to the power of 4 times x to the power of 4, which is x to the power of 8. And then I've got y to the power of 9 times y cubed, which is y to the power of 12. That would be your lowest common multiple. Question number 18. In a school, there are 7 teachers in the maths department, 8 teachers in the English department, and 6 teachers in the science department. The head teachers select 2 of these teachers from different departments to take part in a staff competition. Work out the percentage of all possible selections that contain 1 teacher from the maths department and 1 teacher from the science department. Give your answer to 1 decimal place. So we can either pick a maths and an English teacher, a maths and a science teacher, and an English and a science teacher. Those are the different combinations that we can have. And we can do 7 times 8 for maths and English. We can do 7 times 6 for maths and science. And we can do 8 times 6 for the number of teachers that we could pick from English and science. There we go. So that's going to be 56 different pairings from maths and English, 42 different pairings from maths and science, and 48 different pairings from English and science. All together, if we add that together, we're going to get the total different number of combinations of teachers that we could have. That is 146. and how many of them are from maths and science. That's what they want, maths and science. There are 42 of them. So 42 out of 146 times by 100 gives me a percentage of 28.767. So to one decimal place, 28.8%. There we go. Question number 19, solve x squared is less than 7. So the way that I would solve this, it's a quadratic. So I would actually write x squared minus 7 needs to be less than 0. And that would factorise to be x minus root 7, x plus root 7 if we're thinking about the difference of two squares. Now let's give that a little sketch. I know that my quadratic would cross at minus root 7 and positive root 7. Those are the values that would make that quadratic equal 0. And it would look a little bit like this. So when is that quadratic less than 0? Well, it's less than 0 between those two values. So my answer here, when is the quadratic less than 0? It's when it's between minus root 7 and positive root 7. Question number 20. A is 2, 6, B is 1, 9, and C is 15, 2. Work out the equation of the line that is perpendicular to AB and goes through C. To get the gradient of AB, we need to do rise over run, or change in Y divided by change in X. So if I'm looking at how much it has gone up by, I'm going to do 9 take away 6 divided by 1 take away 2. So we have to go the same way. So how much has gone across, how much has gone up, and we've got 3 over minus 1, which is minus 3. So that's the gradient of AB, but I don't want to go parallel to AB, I want to go perpendicular. So we need to do the negative reciprocal. If AB has a gradient of minus 3, then to go at right angles to that, I want to have a gradient of a third, because that's a reciprocal, and it's going to be positive. This line has a negative gradient, so this line would have a positive gradient. So y equals a third x plus c is the equation of the line so far, and we want it to go through this point. So I want this to go through 15, 2. Now 15, 2 has an x coordinate of 15 and a y coordinate of 2. If we substitute those values in, we can work out what c would need to be in order for it to go through that point. So 2 is a third of 15, add c, so that is 2 equals 5 add c, and so c has to be minus 3 in order for this to be correct. So the equation of my line is y equals, let's put minus 3 there, y equals a third x minus 3, because you would have to take away 3 from 5 to get 2. That is the equation of the line. Question number 21. The histogram shows information about the race times of some runners. The histogram is incomplete. 110 of the runners finished the race in less than 50 minutes. So this section here, we know the area of that bar, because the area of the bar is the frequency on a histogram. The area of that bar is 110. All of the runners finished the race in less than 100 minutes. In total, 200 runners finished the race, complete the histogram. So we've got a bar missing here, and we know that all of the areas need to add up to 200 because that is the total frequency. Now this bar here has a width of 50. So if I do 110 divided by 50, I will find out what the height of that bar needs to be in order for that area to be correct, and that is 2.2. So this here must be 2.2. And that leads me nicely to believe that this is 1 and this is 2. And each little square is 0.1. So that's 110. I can now work out that this point here, the height of this bar over here, is 1.4. So it's 1.4 tall and it's 40 tall. So 40 times 1.4 gives me an area of 56. So 56 people ran between 60 and 100 minutes. Adding that together, I've got 166 people taken care of so far. So 110 runners in the first category, 56 in that last category. So 166 runners, we already know where they finished. So this middle part here, we know that's going to be the rest of the runners because we were told that no one took longer than 100 minutes. So 200 take away 166 is 34. So there are 34 runners that need to go in this middle category here. Now we know that that has a width of 10 because it goes from 50 to 60. So I want it to have an area of 34 and we know it has a width of 10. So 34 divided by 10 gives me a height of 3.4. So I'm going to be going up to here. So that bar there looks a little bit like that. Perfect. And that would have an area of 34 and then our histogram is fully complete. There we go. Question number 22. F of x is x lots of x minus 2 and g of x is x minus 3. Simplify f of g of x over g of f of x. Now these are composite functions. So when we say f of g of x, we are saying let's put x into g and then whatever we get out of it, we'll take that and we'll put it into f. So x going into g gets me x minus 3. That's what that function does. I'm then going to take x minus 3 and put it into f. Now you put it into both places that you see the x. So it's going to be x minus 3 lots of x minus 3 minus 2. So that's the numerator and we'll simplify that in a minute. Now on the denominator we're doing it the other way round. G of f of x. So we're putting x into f and then we're taking that and putting it into g. So x into f gets us this, x minus 2, and then we're putting that into g. So we're picking all of this up and putting it here. So it's going to be x minus 2, take away 3. Now let's just sort that out. So at the numerator, I've got x minus 3 multiplied by x minus 5, because I've got minus 3 minus 2. On the denominator, I've got x squared minus 2x minus 3. So let's factorise this, because if it's going to simplify, we're going to want that in brackets. And that factorises to be x minus 3, x plus 1. And on the numerator, we've got x minus 3, x minus 5. So we're looking for a common factor, and we're going to be able to divide by x minus 3. So that leaves me with x minus 5 over x add 1 as my final answer. X minus 5 over x add 1. Question number 23. The equation of a curve is y equals x squared minus 4x add 3. By completing the square, work out the coordinates of the turning point C. You must show your working. So we're going to complete the square here. And to complete the square, we half that 4. So it's going to be x minus 2 all squared. Take away that number squared and then bring down the plus 3. So that's going to be x minus 2 all squared minus 1. The minus 4 add the 3 makes minus 1. The turning point is whatever makes this bracket equal 0. So that's going to be 2, the value of x. And then just this number here is going to be our y coordinate. So 2 minus 1 is the coordinates of the turning point. That's completing the square. For part B, the curve is translated 3 units to the right and 1 unit up. The translated graph has equation y equals f of x. Work out f of x. So I've got x minus 2 squared minus 1. Now if I'm going to move it 3 units to the right, then I'm going to change the input here. But I'm going to do the opposite of what you'd think. So if you want to move it 3 units to the right, the x is going to become x minus 3. So it's going to be x minus 3 minus 2 squared. And then I want to go 1 unit up. Well, we're already at minus 1. So if I add 1 after, that's going to move it 1 up. So all together, here we go. X minus 3 minus 2 is x minus 5 all squared. And then I've got minus 1 plus 1. So f of x is x minus 5 all squared. There we go. Taking away 3 on the input moves it 3 to the right. Adding 1 after moves it 1 up. Question number 24. ABC and CDE are straight lines. The area of the triangle, BD is parallel to AE. The area of triangle ACE is 135 centimetres squared. Work out the length AE. Give your answer to 1 decimal place. So we want this length down here. Let's put an X there. And we know the area of the big triangle is 135. Okay, let's start then by doing a cosine rule. I would like this length here. I can also get the area of this triangle by doing half AB sine C. So let's do both of those things. I think I'm going to start with half AB sine C. So half AB sine C gets me the area of the top triangle. Half times 15 times 16 times sine 150. Once I've got that area, I can compare it to the area of the whole thing and we can get a scale factor then. So 0.5 times 15 times 16 times sine 150. And that means the area of that triangle is 60 centimetres squared. Now the area of the whole thing is 135. So if I do 135 divided by 60, that's going to give me the area scale factor, and that is 2.25. Let's put ASF. Now, if you know the area scale factor is 2.25 and you want the linear scale factor, you can square root that value. And the square root of 2.25 is 1.5. So that's our linear scale factor. We now know to go from the small triangle to the big triangle, it's 1.5 times bigger. So now if we can get y, I can multiply it by 1.5 and get the value x that I want. To get y, we're going to use the cosine rule. So a squared equals b squared plus c squared minus 2bc cos a, and little b and little c are given by 15 and 16. So 15 squared, add 16 squared, minus 2 times 15 times 16 times cos 150. Let's type that in my calculator. And don't forget that once you've got this value, you are going to need to square root it. Oh, 15 times 16, typing wrong numbers in. Times cos 150, and that's a squared, so a squared equals 896.692, and we're going to square root that value, so a is 29.9448. That, however, is y. So in order to get x, the value that they're asking me for, I'm then going to multiply that by our linear scale factor, which is 1.5, to get to the length on the other shape. And that gives me 44.91722, what we asked to round it to, 1 decimal place. So my answer there is 44.9. Question number 25. A bag contains 3 red counters, 4 green counters and 7 blue counters. A counter is taken at random from the bag and not replaced. 1 counter of each of the colours that was not selected is then added to the bag. A second counter is then taken at random from the bag and not replaced. Work out the probability that after this, the number of red counters in the bag is the same as the number of green counters in the bag. So I'm going to use a tree diagram to try and work this out. So I've got my first pick, which is either going to be red, green, or blue. Now the probability of red is 3 out of 14, that first pick. The probability of green is 4 out of 14, and the probability of blue is 7 out of 14. Now, if we come up this top pathway, if we take a red out the first time, we're then going to pick again, red, green, and blue. But if we took a red out the first time, we've now got 2 red left, but green has gone up to 5, and blue has gone up to 8 because it says we're going to put 1 of each of the colours we didn't take in. We've taken 1 out, but we've put 2 in. So now it's out of 15. So 2 out of 15, 5 out of 15, and 8 out of 15. Now we're looking for the probability that after this, the number of red counters in the bag is the same as the number of green counters. If I take a red one out, I'm going to have 1 red left and I'm going to have 5 greens. If I take a green one out, I've got 4 and 2. So there's no way up here that this can make what we want. So nothing up there is satisfying what we actually want to happen. So that's no good. Now let's look at green. If I take a green one out, then the next pick for red, for green and for blue, we're going to have taken a green one out. So we've now got 3 and it will be out of 15 for green. But we've got an extra red and an extra blue. So red now becomes 4 out of 15 and blue now becomes 8 out of 15 because we had 7 to begin with. Now if I take red out, I'm then going to have 3 reds and 3 greens left in the bag. So we are interested in that pathway. That's good. If I take green out, we're going to go down to 2 and 4. It's not going to match. And if I take a blue out, again, it's not going to be any good. So that's perfect. We want that top pathway. That one is great. Now for the bottom one, if we take blue out to begin with, we're then going to take red, green or blue. If I've taken a blue one out, that's gone down to 6 and it'll be out of 15. I'm then putting one more red and one more green, in the bag. So that's 4 out of 15, and that is 5 out of 15. Now, if I take the green, that will reduce that by 1 and they'll end up the same. So those are the two pathways that I want, green, red and blue, green. So this one is 4 out of 14 times 4 out of 15. We'll get that answer. And this one down here is 7 out of 14 times 5 out of 15. So we're going to get that answer as well. We'll then add those two values together. So 14 times 15, let's get the denominator of 210 for both of them. This one's going to be 35 out of 210, and this one's going to be 16 out of 210. Let's then add those together. So my final answer is 16 over 210, add 35 over 210, which is 51 out of 210 as my probability that there would be the same number of red and green. Very tricky, that one. Oh, that was it. Okay, fab, we're done. Great. Okay, I hope you enjoyed that. I hope that helped. Thank you so much to First Class Maths, obviously, for writing the paper, and I hope that my solutions made sense and you enjoyed it. Let me know what you thought in the comments. Thanks, guys.